Right. Well, we could take the derivative of the first derivative, we could take the derivative of the second derivative. Right? It's called the third derivative. Right? What's the change in our acceleration? Right? And in physics, this is used more in physics. That's why we don't use it as much in this class because we don't do as many physics problems. But it is something that is used a lot in physics. It's does have a name. So like we have the velocity is the so in physics if the rate of change function is the velocity function, the second derivative is the change in my velocity, which is acceleration. The third derivative is the change in acceleration, right? How fast is acceleration changing? And it's called the jerk function because the best way to describe it is suppose again going back to my driving analogy. Suppose I'm driving down the road and I slam on my brakes, right? I slam on, I hit them really hard. Or I'm at a stop sign and I'm revving my engine up, and as soon as that light changes to green, I'm gonna slam my accelerator, right? I'm gonna hit that gas pedal and I'm gonna take off. Alright? That motion of fast acceleration, where my acceleration's increasing, or fast braking, which would be fast deceleration, that's what this third derivative is looking at. And if you think about it, when you do that, there's a jerk to it, right? Right. There's your body actually has a jerking motion, which is why it's called that, because that's kind of what it looks into. And so it's the rate of change in my acceleration, right? And it's really just the third. I take the derivative again, one more time, the third derivative. So if you ever see those physics T-shirts and it has this symbol in it, right? That's what it means. So it means it's the change in my function 3 times with respect to my variable 3 times. So it's the third. All right, so this is the same function that we had in the previous example. So the first derivative, the velocity was 12x cubed minus 6. The acceleration was 36x squared. Right, so that was the velocity, the acceleration. And now the third derivative, which we write with either a third prime or, again, I'm taking the derivative 3 times of my function with respect to x 3 times. Which again, this one's just a simple power rule. I take 36 times 2 to get 72, x raised to the first, and there would be the jerk equation in physics. Again, we're not going to use this one as much. For this class, we typically stick to first and second derivatives. All right, so I'm going to do a second example. All right, so again, one more, and I'm going to do fractions just because students tend to struggle with fractions. So x raised to the 1/7. Right. And in this class, you get to use your calculator. So if you struggle with fractions, just use your calculator. Now, do leave everything exact. All right, so the first derivative would be 1/7 x raised to the 1/7 minus 1, which would be negative 6/7. The second derivative would be, pull out my negative 6/7 times my 1/7. So it would be negative 6 over 7 times 7, which is 49. X raised to the negative 6/7 minus 1, which write it exact, is exactly negative 13/7 is the fraction. Because remember, this really represents the root. This is the 7th root of my function. And then the third derivative. Right, using this notation, or again, the other notation, derivative 3 times with respect to my y, taking the derivative of my function 3 times with respect to x 3 times. Again, it's just ugly fractions. You get to use your calculator, so you can take this fraction, negative 6, and if you need to write it out, write it out. Negative 6 over 49 times negative 13 over 7. X raised to the negative 13 over 7 minus 1. And then use your calculator to simplify. Right? So this simplifies up here to 78 over, so it doesn't simplify real nice. Actually, it doesn't simplify at all. It's exactly the fraction, 78 over 343. And then x is raised to the negative 20 over 7. And leave it like that. On the homework assignment, they typically have you leave them as fractions. Because again, this fraction represents a root. This would be the x raised to the 20th, where I've got the 7th root of x. All right, and so there's that. Just kind of practicing the third derivative with ugly fractions. All right, you can continue. Again, we won't. But you can. You can continue to take more. You can take as many derivatives as you want. And if you take like differential equations or something like that, they go into this more and look at patterns. Since there are patterns to derivatives. But I can take as many derivatives as I want. I could take 3, 4, 5, 6, 7. And what they do is they replace then with, instead of doing like 4 primes, 5 primes, 6 primes, so after the third derivative, they start replacing this up here with a 4. Alright, so this would be the derivative 4 times of my function with respect to x, 4 times. Alright, again, they replace whatever this is, the derivative n times with respect to y, or with respect to x n times. Alright, and I can take as many derivatives as I want. Now I'm going to do one example taking it to the fourth derivative, just to show you it. So I'm going to do one example going to the fourth derivative. But again, for us, we're really going to stick with the first and the second, and you should be able to find the third. But we won't do the third as much. You should just be able to find it. We're not going to do anything with it. The one that's applicable for this class is the first and the second. All right, but I'm going to find the fourth, just to show you that it's just taking 4 derivatives in a row. Alright, so the function that I'm going to take the fourth derivative, I'm going to kind of throw a little bit of everything at you. So I'm going to take 10x to the fifth minus 6x squared, x raised to the fraction 1/2, so that's the square root function, minus x raised to the negative 1, so that would have been 1 over x, right? Well, x raised to the negative 1. So I kind of threw some nice ones and then some ugly ones. And then it's just basically take 4 derivatives in a row. Right? In order. So, and I skipped my first derivative. All right. Have to take 4 derivatives to get to the fourth derivative. All right. So the first derivative, so again, it's all just power rules, all ready to go. So the first one's going to give me 50x to the fourth. The second one's going to give me negative 12x to the first. Then I get 1/2 x raised to the negative 1/2. Here I'm going to get negative 1 times negative 1, so it's going to come out positive 1 x raised to the negative 2, right? I subtract 1. All right, there's my first derivative. That's my velocity, change in my function with respect to x. Now my second derivative, so again, do the same process. So 4 times 50 is going to give me 200. All right, 100, 200. X cubed, this is just negative 12. Here I'm going to get negative 1/2 times positive 1/2, so 1/4, negative 1/4. X raised to the negative 3/2. Here I'm going to get a negative 2, x raised to the negative third. All right, there's my second derivative. So I'm changing my function with respect to x twice, which would be my acceleration. Now my third derivative, all right, so this would be 600x to the second. The 12 zeros out, it's gone. Here I'm going to get a positive, right? The negatives cancel out, 3/8. X raised to the negative 5/2. And here I'm going to get a positive 6, x raised to the negative 4th. All right, and so there's my third derivative. So that's the jerk function. That's the rate of change in my acceleration. So it's the change in my function with respect to x 3 times. And now the last one, the fourth one. This is the last. Again, I could keep going if I wanted to, but I'm going to stop at the fourth one. All right, so the fourth one is going to give me 1200x to the first minus 15 over 16, right? 5 times 3 is going to give me 15. 2 times 8 is going to give me 16, but you can use your calculator. X raised to the negative 5/2 minus 2 is going to give me negative 7/2. And then here I'm going to get a negative 24, x to the negative 5th. And there is my fourth derivative. Now, again, I could keep going. And this function has infinitely many. Now, eventually this first one will zero out. But the fraction and the negative power will keep going. They actually have infinitely many derivatives. Now, again, we're not going to do that. And there is a pattern to them. Like I said, that would be if you took a differential equation class, they'd talk about that. We're going to stop there. But you could see, you could keep going, right? I could take a 5th derivative, 6th derivative, 7th derivative, and so on. Again, in this class, we will use really the first and the second derivative for the most part. The velocity and the acceleration for this class are the only two that are really applicable, because we don't get into the physics stuff. So first and second derivatives are the ones we're going to do the most. But you should be aware you can do as many as you want. All right, we'll get into applications of velocity and acceleration in the next set of notes.